Alright, continuing with our exponent rules, we're going to start talking about multiplication properties of exponents today. There are 3 properties of exponents for multiplication. This will not be a one-day lesson. We will probably do the rules. We will talk about them. We will practice. It will take a little bit longer than one day. So if you're watching this, just remember it will be a 2-day lesson. And it is not actually divided into 2 days in this video like some of the ones have been in the past. Alright, so the first rule we're going to start with is product of powers. So we will fill this out on your whole rules sheet as well. Alright, but the product of powers rule says if we have 2 variables here with the 2 expressions, we've got the same base, they're both x's in this case, then we can take and add the exponents. They have to be the same base in order for this to work. So let's look at example 1. Here are the bases. They are the same. They are both x, so we will write down the base of x. Next, we are going to look at our exponents. So we have 2 and 3, so we add those together. We have x to the 5th power. That is my simplification of this rule. X to the 5th power. I'm just adding exponents. Example 2. The first thing I'm actually going to do for all of these is really multiply the numbers, the coefficients in front. I have a 3, and I technically have a 1 over here when I don't have anything. So I'm going to bring that down as a 3. 3 times 1 is 3. Then I'm going to look at my bases. My bases are the same, so I'm going to bring my base down, and I'm going to add my exponents. 2 plus 3 is 5. So 3 to the 5th power. Alright, example 3. Again, multiply the numbers. 3 times 2 is 6. Then I'm looking at my bases. X and x. The bases are the same, so bring them down. I don't have an exponent here. If you do not have an exponent here, it is an exponent of 1. They just don't put an exponent of 1. So I'm going to add them together. 1 plus 2 is 3. One of the biggest mistakes that gets made is that somebody will put this is x to the 2nd when there was an x right there. That will be a problem if you forget that there is a 1 there. Okay, the next multiplication rule is a power of a power. Close this. Product of powers, power of a power. That means I'm raising one thing to the other. This is very much like the distributive property, meaning I'm going to take this and almost, distribute it in there. So when I distribute, I'm multiplying. So this is A times B. So example 1. If I take this and I multiply it by 4, I have 4 times 2, so x to the 8th power. Example 2 and 3. Again, if you're doing this on your own, it's a good idea to pause it, figure it out, before you just get the solutions or the simplification. 2 times 2, b to the 4th power. 3 times 4, n to the 12th power. Probably my favorite one. They do get more complicated than that, and you're going to see that in just a moment. In a power of a product. So power of a product. Power of a product is very similar to power of a power. There's a reason I told you about the distributive property, because that is what a power of a product really is distributing it to everything inside the parentheses. So this, I would have x to the a and y to the a. I'm just distributing it into everything. That means this 4 goes with the 4 and to the x. 4 to the 4th power, x to the 8th. I'm combining the two rules that I've had now. 4 times 2 is 8. I'm not finished. I do need to simplify and find out what 4 to the 4th is. Anytime I have numbers, I need to go ahead and figure it out. 4 to the 4th power is 256. So my simplification is 256 x to the 8th power. Number 2 and 3. Again, 2 needs to go to everything. The 3 and the v. So 3 squared and v to the 6th. 3 times 2 is 6. Then I need to simplify the numbers. 3 squared is 9, so 9v to the 6th power. Example 3. 4 to the 4th, to y, to the x. There are 3 bases, so you need to raise the exponent to all 3. 4 to the 4th, y to the 4th, x to the 16th, 4 times 4. 4 to the 4th power is 256, as we saw in example 1. Just to put this, like I said, we haven't talked about standard form yet. We will soon. But let's put it in alphabetical order. So x to the 16th, y to the 4th. Like I said, this will be a 2-day lesson. We will continue by doing some more examples. There are quite a few of them. There are actually 14. It is a mixture of all of these rules, so they're no longer going to be all together. Alright, so we have all of our rules that we have learned so far. We've learned the integer exponent rules, where if you have a negative exponent, it's going to move either from the numerator to the denominator or the denominator to the numerator. We have zero exponent rule, where if it is anything raised to the 0 power is 1. We have product of powers, power of a power, and power of a product. All of those will be seen in these 14 examples. Number 1, we're always going to start by looking at our numbers. So we have 3 and we have 2. This is a multiplication symbol between them. We are going to multiply our numbers just like we normally would. 3 times 2 is 6. That takes care of the numbers. Then I need to look at the bases. M and M are the same base. Remember, if there is no exponent, it has an exponent of 1. We are going to, because we have multiplication here, going to add these bases. M to the 3rd power. I do not have anything else to simplify, so I'm finished. Number 2, multiply numbers. 4, add exponents into the 4th. Pause. I would pause this and go ahead and try number 3 on your own. If you need an if you need a placeholder 1 there, you can put it there. 3 times 1 is 3. Add exponents, 6. Make sure you add exponents, not multiply them. Numbers 1, 2, and 3 were all the product of powers rule. Now we are going to talk about the power of a product rule again. This is, like I said, like distributive property. It's distributed to every piece. -3, notice it's in parentheses, to the -4th. and n negative times negative 16. Alright, now I have a negative exponent. And when I have a negative exponent, I'm going to have to take care of that. Negative 4 is directly tied to negative 3. Therefore, it needs to go to the denominator. N to the 16th is positive, so I'm going to leave it in the numerator. And I keep saying leave it in the numerator. Remember, there is always a fraction. Everything is always divided by 1, which makes our fraction, which is where I mean we're going to leave it in the numerator. That's where that's coming from. Alright, and then we have negative 3 to the 4th power. Negative 3 to the 4th power is going to be 81. And we leave the 16, the n to the 16, right where it is. So there was a combination of a couple of things. We had negative exponents we had to take care of, and we had some simplification. I would pause this and try number 5 as well. So, like distributive property, 3 to the 4th, v to the 8th. We then need to do 3 to the 4th. I have 81 v to the 8th power. Numbers 6 and 7 are zero exponent rule. Here's a 0, which is directly tied to this entire thing. Since the 0 is with the whole thing in parentheses, this entire piece is 1. Again, number 7. 0 is directly the exponent for the entire piece there. So it is also 1. Saves you some time. Numbers 8 and 9 are like 4 and 5. So I would pause it, try those on your own. Since it is an exponent on the outside, we are going to distribute. Even though this is a negative and your first instinct might be to go ahead and make it a positive exponent, it's a good idea not to, so that you can, sometimes it'll come out as a positive here. So negative 2 times negative 3 becomes a positive 6. That's why it's better to wait till the end to kind of fix it. I do need a fraction because I have a negative exponent with the negative 3. So 2 to the 3rd power goes on the denominator. X to the 6th stays in the numerator. 2 to the 3rd power is 8. And x to the 6th over 8 then is our simplification. Okay, number 9. 3 goes to 2. 3 goes to the x exponent and to the y exponent. Zoom in a little bit. 2 to the 3rd power. X to the negative 6th power. Y to the 12th power. This is, we've looked at every piece, we've done this before, but we really have to pay attention to every single piece. 2 to the 3rd power, there is no negative there, stays in the numerator. X to the negative 6, 6 is negative, so it needs to change from the numerator to the denominator. And then y to the 12th is not negative. We then need to finish simplifying 2 to the 3rd, which is 8. 8y to the 12th over x to the 6th. Ten through 14 are a combination of every single rule. It is a good idea to go ahead and pause this, look at them, try to think about them for a few minutes, and then we'll go through and solve them. Alright, now that you've had a minute to look at these, let's talk about them. We're combining all of the rules we've learned together. We're going to just go left to right like you're reading a book. So I, first of all, have these parentheses, and I'm going to deal with those first. 4 raised to b, as well as 4 raised to a squared. We have b to the 4th and a to the 8th. Remember, it's to the 8th because I'm going to multiply the exponents together. Alright, then I'm just going to bring down times a to the 3rd and times b to the negative 3. It's a good idea sometimes to put all those there to know exactly what's going on. Because I'm just going to go in alphabetical order, let me straighten that out. I'm going to look at the a's first. These are my like bases, a and a. So I'm going to write down a. I am now multiplying, which means I'm going to add the exponents. 8 plus 3 is a to the 11th power. Okay. Then I have the b base. I'm going to add 4 plus negative 3 is 1. I can either put a 1 or I could write the answer as a to the 11th times b. Either way is correct. It's a good idea to always combine things so that you do not have to worry about moving anything to the denominator until you have seen if the negatives will take care of themselves first. So there's number 10. Number 11. Again, I'm going to start with these left to right. So x to the 4th, y to the 6th because I'm multiplying, and I'm going to bring down times 2, x to the 3rd, y squared, times anything to the 0 is 1. And now I'm going to multiply my numbers. There is a understood 1 times 2 is 2 times 1 is 2. So my coefficient is 2. Then I've got the x's. Base of x, base of x. So x to the 4 plus 3 is 7. And I'm adding because I don't have any more exponent to an exponent anymore. I'm just multiplying all these together. Then I have y's. Y to the 6th, y squared. 6 plus 2 gives me y to the 8th power. Number 12 is a lot, and we're probably not going to have tons of room. We might not have enough room. We'll figure it out. But negative 2 has to go to everything. 2 to the negative 2. X to the positive 6. Negative times a negative is positive. Y to the negative 8. X to the negative 4. Y to the 8th. Oh, this actually might not. We might not have to move too much. Okay, we're going to bring it down. 2 to the negative 2, I'm just going to bring it back down. Alright, then I'm going to look at bases. X and x. 6 plus negative 4 is x to the 2nd. Y bases. Y, negative 8 plus 8 is 0. My y's are going to just go away. So I'm just going to cross them out. Those two are going to cancel each other out. Alright, now, I do now have a negative exponent that I need to take care of. 2 squared needs to go in the denominator. X squared is not a negative exponent, so it's going to stay in the numerator. Then I'm going to simplify x squared over 4 is my simplification for that question. Okay. Last two questions. 13. You can distribute that in. Y to the negative 2, x to the negative 8 times 2 times x. Again, I've got my number, so just plain 2 here. Then I have an x base, sorry, not coefficient. Remember, there is an understood 1 there. Negative 8 plus 1 is x to the negative 7. So I've got a problem. I've got some negative exponents. I'm going to have to take care of that in a minute. Y to the negative 2 has no other like base, so we just bring it down. Okay, now we have to worry about changing where things are located. 2 does not have a negative exponent directly tied to it, so it is just 2 in the numerator. x to the negative 7th. To make that a positive 7, we're going to move it to the denominator. Y to the negative 2, bring that down to the denominator. So we have 2 divided by x to the 7th, y squared. The next one is very similar, so again, it's always a good idea to pause and try to figure them out for a few minutes. But let's go ahead and look at 14. 2 gets to go with everything. 2 squared, m to the 4th times n. Actually, this one was not as bad because we don't have any negative exponents. 2 squared is 4, and then we have m to the 4th times n. And we are finished. There are no negative exponents and no zeros. There are some quick examples for multiplication properties of exponents.